that done. So this is section 14.6, surfaces. We're going to talk about graphing surfaces. Because we're in 3D, we're going to call them surfaces as opposed to just curves, okay? And they're not going to be solids because they're not all enclosed. Do we understand that? They're not enclosed, so some of them will be, but majority of them are not solids, okay? So before we do that, let's just recap what we know how to graph. Cool. So what do we know so far how to graph yet in 3D? Okay. We know how to graph lines, correct? In essence, you just find 2 points and you connect them. Okay. And the equation of the line was what here? We had a couple different options here, 3 different types, but I'll write the parametric equations. So we know how to graph lines. We have x is equal to x naught plus at, y is equal to y naught plus bt, and z is equal to z naught plus ct. So far we know what that looks like, correct? Then we have planes. Planes are something like this. We have a times x minus x naught plus b times y minus y naught plus c times z minus z naught is equal to 0. We know what that looks like. Then we also had one more that we kind of talked about, which was spheres. If you recall, the equation of the sphere was what? X minus x naught squared plus y minus y naught squared plus z minus z naught squared is equal to r squared. So that's what we've done so far in terms of 3D stuff. Today we're going to take a look at 2 more types of 3D graphs. We're going to look at something called cylinders. And the last thing we're going to do is quadric surfaces. So this is in this section. This is in 14.6 that we're going to take a look at. Before I do that, let me just quickly, I don't think so I mentioned how to graph a plane, but let me just show you an example. So let's say if you have 2x we have 2x plus 3y plus z is equal to, let's say 6. This is a plane. Again, you have to recognize what it is, and that's why I gave you this. So these 3 things we should be able to recognize now. This looks like this. Okay. So we want to graph the plane. The best way to graph a plane is just start with the intercepts. So if you want to graph this plane, so on the test, if I ask you to graph a plane, all you do is start with the intercepts. So the x-intercept is what? You said y and z to 0, so what do we get? If you said y and z to 0, what do we get for x-intercept? So we get 3, 0, 0. The y-intercept here is, you set x and z to 0, so we get 0, 2, 0. And the z-intercept is, you set x and y to 0. So you just plot it. So we have, let's scale by 2's. So that's my x and z-intercept. If I scale by 2's out here too. So that's my z-intercept, this is my x-intercept, 3, okay? And my y-intercept is 2. So once you have those, all you have to do is connect the points and create a triangle. Is that okay? And that's technically your plane, because what happens, this it'll basically keep extending in that direction. So you guys follow, it'll start spreading out. Okay, we're not going to be able to draw all of it, but if you wanted to, you could imagine this side will increase, this side will move this way, this side will move this way, this side will move that way. It'll spread out, you know, and create the plane. So the best way to draw a plane is to start with a triangle and just imagine it stretching out. Are you okay with that? Right? But we are more interested today in drawing quadric surfaces. So how do we do that? Well, first of all, we're going to need some terminology, 2 things. So we're going to talk about cylinders. So before we talk about cylinders, let's talk about something called a trace. So traces are curves formed by the intersection of the surface with a plane parallel to the coordinate plane. Basically, in a nutshell, all it is it's basically a cross section of a surface with a plane. How many coordinate planes do we have? We have 3, right? XY, YZ, and XZ. We have 3 coordinate planes. So this is what a trace looks like. So for example, let's say that I have a cone. So this is Y, X, Z. So if I have a cone, okay, if I were to take a slice of this cone parallel to the XY coordinate plane, okay, so if I take a slice of this cone parallel to the XY coordinate plane, XY coordinate plane is this flat region at the bottom, correct? So if I slice it, let's say if I slice it right here, so this is Z is equal to, let's say this point here is 3. So this plane is Z is equal to 3, because when Z is 3, X and Y could be anything, right? So that's going to be parallel to the horizontal plane, you know, the XY plane. Okay. So if I take the cross section, what do I get? I get a and this is called a trace. So the trace basically is what you get when you slice a surface with a plane that's parallel to the XY plane. So you don't want to slice the surface at an angle. Do you guys understand that? It has to be parallel to the one of the coordinate planes. Okay. So trace is just the outline of that shape. So in this case, the trace would be the circle. Okay. So the next thing we need to talk about is cylinder. So cylinders are equations that look 2D but live in 3D. So the equations that look like in 2D. What do equations in 2D have? They have only two variables, right? X and Y. So a cylinder is an equation that looks like in 2D. Either it'll have X and Y, or it'll have Y and Z, or it'll have what? X and? It'll only have two variables. Do you guys follow? So that's called a cylinder when you only have two variables. So a cylinders are equations that look 2D but live in 3D. Okay. Generating curves which are basically traces. I'll put in parentheses traces. Exists in one coordinate plane, and the surface is created by dragging the curve in the direction of the free variable. It'll make most sense when I draw a picture here, what I mean by it. So basically what's going to happen is you have a curve that is missing one variable. Do you guys follow? So you start with this trace. Okay, once you have that trace, then you just extend that trace in both directions. In the direction of the missing variable. So in both directions of that missing variable. So for example, let's say if I give you this, z is equal to y squared. As soon as you see a variable missing, you know it's a cylinder. Is that okay? So in this case, we know this is a cylinder. It kind of sounds goofy. It's not going to look like a cylinder. We just call it a cylinder. Okay. So in this case, which direction are we going to extend this cylinder in? In the x direction, both in the positive x direction and also in the negative x direction. So we start with what this looks like in regular XYZ plane. So what does that look like? A parabola? Okay. So we start with that. So we have some type of a parabola here. So this is my, and this is my trace, by the way. Why is it my trace? Because a trace is like a cross section of the surface, right? If I were to take this surface, z is equal to y squared, and take the cross section with the yz plane, won't I just get that shape? Do you guys understand that? Remember what I said trace was when you slice it with a plane, right? In this case, what plane are we slicing it with? Y, z plane. And now what do we do with this parabola? We extend it in the x direction, right? Okay. So I'm going to take this and just drag it out in the x direction. So you'll basically get shapes like this. So if you start connecting all of these green curves, you'll get a sheet that's folded like in a U shape, you know? Everybody understand that? So if you look at it, it's going to look something like this. It's going to be a sheet that's folded in a U-shaped form, you know? Okay? And it's just going to be like a gutter, you know? And that's what it's going to look like. So that's a cylinder now. So we call this a cylinder. So the cylinder is a 3D representation of a trace, really. You guys follow? You start with a trace, you extend that trace in the missing. I only extend it in the positive direction. Remember, it also goes in the negative direction, but it's harder to draw, so I'm just going to draw it in the positive direction. Okay, but technically it should also go in the back direction where you would have a parabola like this, you know. Everybody okay with that? So all you do to create a cylinder, you start with a trace and you extend a trace. That's all you're doing. And the trace is always in one of the coordinate planes since one of the variables is missing. The trace will always be in one of the coordinate planes since one of the variables is missing. So for example, how would you do this then? And a lot of the times, just so you guys know terminology wise, you know, you would connect this with some, you'd shade it, you know. I can't do it because I have different colors I can use, but you would shade this, right, to create that surface, you know. And those lines parallel to the x-axis are called rulings. Rulings are lines that are parallel to the axis that you're extending it in the direction you're going in. Those horizontal lines, you know. So these horizontal lines that you would have are called rulings. Okay. Are you okay with that? So those horizontal lines that you have are called rulings. The whole thing is called a cylinder, and you start with a trace. Any questions on cylinders? So for example, well, let me do two examples really quick. This is something you should recognize. If I give you this x squared over 4 plus y squared is equal to 1. What does that look like? It's an ellipse, right? So, but I'm missing a variable. We're in 3D, so if I'm missing a variable, this is going to generate what? Something called a cylinder. Okay. This time we're going to extend it in what direction? Z. So we're going to start with an xy plane. So start with an ellipse in the xy plane. So draw an ellipse in the xy plane, because that's going to be my trace. So this is an ellipse where the one axis is 2 and the other axis is 1. So this is 2 and this is 1. So it's an ellipse that looks like this. So this is 1. So this is the bottom of so this is my trace. What am I going to do with that trace now? We're just going to drag it up, like create a drum, you know, or a cylinder that's oval. So if you just extend it up, and you can also extend this. That whole green surface is called a cylinder. So it's actually going to be like a cylinder, an actual cylinder, except it's going to be oval and it's going to be hollow from the middle. Everybody okay with that? It's going to be hollow from the middle. So this is a cylinder. So let's just do one last one and then we'll move on. See if you guys can do this one. So we did one in the x direction, one in the z direction. Let's do one in the y direction. So let's say if I give you something like this, z is equal to sine x. What does that look like? Again, y is missing now, correct? So this is a cylinder. So this time I'm going to start with what? So I'm going to start with the trace that's in the xz plane. which is just a sine curve, you know. So it looks something like this. Starts at 0, goes down, goes up. So that's my sine curve in the xz plane, so it's supposed to be flat. And then what am I going to do to that sine curve now? We're going to extend it in what direction? In the y direction. So you'd end up with shapes like this. So it looks like a rolling sheet of paper, you know. Pretty okay with that? So it's fairly easy to draw these. Just start with a trace. So this was my trace, the thing I started with. This was the trace. And this whole thing is the cylinder. And those horizontal lines that are parallel to the axes that we are stretching it in are called rulings. Everybody okay with that? Can we move on to the next thing? So the next thing we want to talk about, like I said, are called quadric surfaces. So we want to talk about quadric surfaces. So what are they? They're basically the 3D representations of conic sections. How many conic sections do we have? Technically we have 4: circle, ellipsoid, ellipse, hyperbola, and a parabola. Okay, so these are just 3D representations of the same things. Okay? So they're basically 3D. So let me write down the equation of a quadric surface is a second degree equation in 3 variables. First of all, that's what it is. So it looks something like this. We have ax squared plus by squared plus cz squared plus we have dxy plus eyz plus fxz plus gx plus hy plus iz plus j is equal to 0. So this is a typical generic general equation of a quadric surface. The main thing is it is an equation that is of degree 2. Okay. We'll just put a note. A quadric surface is the 3D presentation of conic sections in 2D. So basically they're just 3D representations of conic sections in 2D. There are 6 quadric surfaces. Okay. So there are 6 quadric surfaces. I'm not going to ask you to draw them, but you should be able to tell me what they are on the test. Do you guys understand that? And I want you to tell me by looking at the traces, and I'll explain what we mean by that. So let's start with the first one. The first one is called an ellipsoid. So the first one's called an ellipsoid. It looks something like this. You have x squared over a squared plus y squared over b squared plus z squared over c squared is equal to 1. I do not want you to memorize this. If I gave you something like this with numbers instead of a, b, and c, I have some numbers, you can't just tell me it's an ellipsoid. You have to kind of tell me why it's an ellipsoid. Okay? Because there's only 6 of them, so you can easily memorize them, but it's better to learn because down the road you might forget what they are. Okay. So the best way to figure out what this looks like is by drawing, by looking at the traces. Okay. So let's take a look at the traces. So the first trace I'm going to take a look at is the xy trace. So to find the xy trace, you basically take z is equal to 0. Because you're looking at the xy plane, if you were to slice it with an xy plane, what does that look like? If you set z to 0, what do we end up with? We get what? So we get an ellipse. So that's what I want to see on the test. You just tell me what it is. That's an ellipse. So we have an ellipse in the xy plane. Then you look at the other traces. So you look at yz trace. So you take x is 0. So we get y squared over b squared plus z squared over c squared is 1. That's an ellipse too. And then you take a look at the xz trace. So please remember that this is kind of what I want on the test, because I don't want you to just blatantly memorize the stuff. I want you to tell me what each trace looks like. So you have 3 traces, they all look like an ellipse. What do you think that shape looks like then? What does that surface look like? What would that look like? You have an ellipse in this direction, correct? You have an ellipse in the other direction. And then you also have an ellipse in this direction. Like I said, it's hard to draw these things, so I'm not even going to try to draw them. But we have ellipse in all directions. What does that shape look like? So this is my ellipse. This is my ellipse in this direction. Then I have an ellipse in this direction, in the YZ plane. And then I also have an ellipse that goes in the other direction like that. So what does that look like? You should be able to recognize that. That looks like a what? Like a football? When you think about a football, that's an ellipsoid, because you have ellipse in every direction. So this should look like a football. I'm not going to draw all of these, but I should have them somewhere here just to show you. So you can see the trace like over here. You can see if you look at this direction, this is the x, and the YZ plane, it's an ellipse, you know. Okay. If I rotate it on the top, if I look at this direction, it's the XY trace. That's also an ellipse, you know. It looks oval kind of, but it's an ellipse. And then if you go the other way, if you look at this direction, which is the YZ direction, oops. The YZ direction, and that's also an ellipse. You guys understand that? So it just basically looks like a football. Okay? So That's an ellipsoid. Just looks like a football. It's got ellipse in all directions. We good? So on the test, I just want you to be able to, if I give you, all I'll do is give you some equations, and you have to be able to look at them. Like if I give you something like this, you have to be able to look at them and tell me what it is by just looking at the traces, and then tell me the word what it is. It's an ellipsoid. Are you okay with that? So just make sure it's fairly straightforward. We don't need to do any graphing with this. Okay. The next quadric surface is hyperboloid. Of one sheet. So the next surface we're going to talk about is hyperboloid of one sheet. Okay. So it looks something like this. We have x squared a squared plus y squared b squared minus z squared c squared is equal to 1. Now this one's interesting because, first of all, if you have one negative, then it's hyperboloid of one sheet. We're going to take the next one is hyperboloid of two sheets that has two negative signs. Is that okay? So let's take a look at the xy trace. Z is equal to 0. What does that look like? I'm not going to write the equations down again. So if z is 0, that last term's gone, right? The third term. What do we get? Ellipse. Okay, so we get an ellipse. If I take a look at the yz trace, I take x is 0. What do I get this time? A hyperbola. And if I take a look at xz trace, I take y is 0. What do we get also? Hyperbola. So this one kind of looks like, again, I'm really terrible at drawing 3D stuff, but it looks like a drum, you know, like one of those African drums. So it looks something like this. Why does it look like that? Look at the xz trace. If you slice it horizontally in the xy plane, what do we get? We get an ellipse, right? Isn't that what we said we have in the xy plane? We have an ellipse. And in the other two directions, what do we have? You see we have a hyperbola. If you were looking at the yz direction. And then we technically also have an hyperbola in the xz direction because you have a hyperbola that's going back, you know. You guys see that? So you can see that it's a hyperbola in all the other directions except in one direction. So if you look at the shape of that, so it should look something like that. So you can see we have hyperbolas, and you can see the hyperbolas drawn out, the traces. Do you guys see that on the wireframe? And you have hyperbolas in both of these directions on the outside and the back, and then you have an ellipse from the top. Looks like a circle, but it's really ellipse. You can see when you angle it. Is that okay? It's oval. So that's what that looks like, hyperboloid of one sheet. Let's take a look at the next one. This is 3. We have hyperboloid of two sheets. This time we have two negatives, so we have x. And obviously, by the way, you guys understand this, right? I could easily change these equations. I could have put z out here and x out here, so all the traces would change. Do you guys understand that? Everybody follow? And that's what will happen. So that's why I need you to tell me what the traces are. Because depending upon how the equation is presented, how the variables are up here, your traces are all going to be in different directions now. Okay? So that's why it's important to look at the traces more than anything. So if I have z squared over c squared minus x squared over a squared minus y squared over b squared is equal to 1. So if you have two negatives, then it's going to be a hyperboloid of two sheets. Okay. So let's take a look at the traces. Go ahead and do that this time and see what we get. We get xy traces what? You notice xy trace, what did we get this time? Huh? Well, because this term will go away, correct? And if you multiply, you'll end up with this. If you multiply by a -1, you know, these are all positive numbers because of all the squares. Can a square equal to a negative number? So are we going to get any trace in the xy plane? No. So in this time, we're not going to get none. Do you understand that, right? Because of the negative numbers, you know, we're not going to get any traces there. So in the xy plane, there's going to be no graph. There's no trace. Okay. What about the other traces? What happens if x is 0? If x is 0, we get a hyperbola. And in the xz plane, what do we get? Are we good? But you have to look at this a little bit carefully. Yes, I don't have anything in the xy plane, in the xy trace. Okay, in the xy plane, I don't have a graph, but I do have a graph if certain conditions are satisfied. Okay, so for example, we looked at when z is 0. Remember, a trace is what? A trace is something that's made with a plane that's parallel to the coordinate plane, right? So we are looking at the very basic trace where z is 0. That's a xy plane. But can't I take a plane that's parallel to that? Can I take z is equal to maybe some number? You guys understand that? If I take z is equal to some number, then I will get some traces, provided that number is satisfied. So let's take a look at that. So let's solve that for x and y. So you get a squared plus b squared is equal to z squared over c squared minus 1. I'm just trying to figure out, I'm trying to get a better handle on what happens if, we know nothing happens when z is 0, but what happens if z is not 0, if z is a number? Do I get a shape that I can live with? So I can simplify this. This right hand side simplifies to what? I get z squared minus c squared over So now what's going to happen? If z is between what? Negative c and c, are we going to get any surface? Look at it. If z is between those two values, won't this be bigger than this then? Because z is smaller than c, and so this will become what kind of a number? Negative number. Can positive equal to negative then? No, so we have no surface. But will we get surfaces for everything else? We will, right? We should get surface for, if z is bigger than c, then this is a positive number, isn't it? Won't I get a surface then for that? What will that look like? If z is bigger than c, or if z is less than negative c, what would that look like? This would be a number, positive number. So it will be what? An ellipse. So we know that, so we can say that if z is bigger than c, or if z is less than negative c, then the trace is an ellipse. So we do get some stuff in that direction, in the z direction, except nothing in the middle between negative c and c, but everything else gives us something. So this looks something like this. Again, I'm going to try to do my best to draw it. So we're going to basically get something like this. You get ovals up here, and then you get another and this is C and this is minus C. So there's no graph in between here. There's no surface in between there. But there's surfaces on the top and there's surfaces on the bottom in the Z direction. So this is the Z direction. This is X and Y. And you can see that on the top we have ellipses. Do you guys see that? Okay. And then you can see there are hyperbolas on this side, which we expected. And there's also hyperbolas on this side, on the back end. Okay. And you can get a better idea of with this. So you get like two, basically exactly what I had there. Do you guys follow? You get two bowls, one opening up and one opening down. Okay. And you can see there are hyperbolas in either direction. If you look at it, if you were to draw them, there would be hyperbolas this way, there would be hyperbolas in the front and the back, And then on the top, there are just ovals. Good? So this is ellipsoid of one sheet, of two sheets. Okay. So the next one we're going to take a look at is, so we took a look at how many of them so far? 3 of them. Okay, so let's take a look at a paraboloid. Well, let's do elliptical cone first. So we'll take a look at an elliptic cone, which looks like this. We have x squared over a squared plus y squared over b squared minus z squared over c squared is equal to 0. So we have YZ plane. What does a trace look like? Come on, we have 10 minutes. We got to run through this. What does the trace look like in the YZ plane? Z is 0, right? So what do we get? We do get ellipse. How? Because the right hand side is 0 now. So you would end up with something like this: x squared over a squared plus y squared over b squared is equal to 0. And then if you were to solve this, you would get what? X squared over a squared is equal to negative y squared over b squared. Is that even possible? On one side I have a positive number, on the other side I would get a negative number. Would that work? The only time that would work is when? X and y are what? 0. Do you guys follow? The only time that would work is if x and y are 0. So we get no surface here. No surface. But we get a point, x equals to y is equal to 0. That does work though, right? Everybody okay with that? So that works. What is the YZ plane trace? X is 0, so what do we get this time? This time the z moves on the other side and we get a nice equation, correct? What do we get though? If you take square roots on both sides, what would you end up with? They would just be what? We have y squared over b squared is equal to z squared over c squared. So this gives me what? Y is equal to plus or minus b over cz, right? If you cross multiply and take square roots on both sides. So what are those called? Aren't they just lines? Similarly, the other one will also give you a line, so I'll let you write that down. XZ plane will also give you lines. Anytime you don't get a surface, you should ask yourself, what would happen if I pick something else? The reason why I didn't get a surface is because I picked Z to be what? 0, correct? But in the last surface, we picked Z to be something else and we did get something, didn't we? If we pick Z to greater. So what happens if Z is a number now? If Z is a number, if Z is no longer 0, then you will get something, won't we? What happens if Z is a number? Let's say Z is 5. So now you have 5 here, it's negative, so you move it to the other side. What do we get then? An ellipse. So we do need to address that. So whenever you don't get a surface, address the situation. So we can say if Z is not 0, then we get an ellipse. The only time we don't get an ellipse is if Z is 0. What do we get if Z is 0 though? We get a point. Do you guys remember X and Y are both 0? So in this case, we just get a cone, a double cone, except it's oval, not circular. So it looks something like this. So this is Y, this is X, this is Z. So we just get an oval cone because you can see these are the lines that we got, in the other direction. So you remember we got lines in 2 directions, and then we got ovals on the top and the bottom. Good? That's all we get from there. So it's.
So are those lines restricted then up to?
No, they keep going in both directions because Z just keeps increasing. The only thing is that's special about these lines that they go through 0, 0 because X and Y are both 0. So they'll go through 0, 0. And in all directions, they'll go through 0, 0. Because if I take Z to be 0, Y would be? So in the YZ plane, they'll go through 0, 0. And so will they go through 0, 0 in the XZ plane. So that's a cone. The next one, 2 more left, is an elliptic paraboloid. So that looks like this. We have x squared Z is equal to x squared over a squared plus y squared over b squared. And again, you don't have to memorize these. Just look at what you get, and you should be able to tell what it's going to be. So let's take a look at the xy trace plane. Sorry. What do we get? Come on, guys. Really? No. Yeah. Yeah, I'm sorry. Yeah, because when you move it to the other side, we'll get a negative number, So we get no surface, actually. A point at 0, 0. Well, all 3 zeros basically get the origin because xy is 0. What do we get in the yz plane? X is 0, so what does this look like? Parabola. And that's why it's called a paraboloid. Is that okay? And in the xz plane, what do we get? Same thing. Now we didn't get a surface in the yz plane, correct? So what should we do? Look at different values of z? So what happens if I look at different values of z? So let's take a look at negative values. If z is negative, then what do we get? Anything? Because you're positive on one side, negative on the other side. Is it possible? No, so no surface again. What happens if z is positive though? Very good. Then we get an ellipse. So basically this graph is going to be above the xy plane. There's nothing below the xy plane because those are the z values that are negative, right? So if you graph it, it should look like an So this is y, this is x, and this is z. So it ends up looking something like this. You have parabolas in the xy direction, then you have another parabola in the other direction, and then we have ellipses if z is positive. Are you okay with that? So it's just a bowl. Okay. And then the last one is hyperbolic paraboloid. Hyperbolic paraboloid. This one is the hardest one to graph, so I'm not even going to graph this one, but it's harder to graph and even to visualize. It looks really weird. But let me just give you the equation. So you have z is equal to y squared over b squared minus x squared over a squared. It's very similar to the last one, except what do we have in the middle now? A negative. Okay. So let's just take a look at the traces. XY trace.
Just give me the line.
If y is 0, so it's just going to be a line. Okay. In the YZ plane. And that's why it's really weird, because you see lines, but when you look at the surface, you won't be able to see those lines very clearly. Do you guys understand? They're really hard to visualize, this one. Parabola. And the XZ plane. Except it'll be what though? Upside down. Do you guys follow? Because it'll be because of the negative, correct? So you have a parabola that goes up, and then you have another parabola that goes down. So it's kind of like this. You have a parabola that's going down, and then you have another one that's going up. So it's really hard to visualize what this looks like. So I'm not even going to bother drawing this for you, but I'll do it on Mathematica so you guys can take a look at it. So that's what it looks like. You can see one parabola going down. Do you guys see that? Okay, there's a parabola out here that's going down, but if I turn it, then there's a parabola that's going up on that side. Is that okay? It looks like a saddle. If you're sitting out here, if you look at a saddle of a thing, that's what it looks like. So the best way to remember this is just remember it as a saddle. Do you see any lines over here? And those are really hard to visualize, but it depends upon the the lines that you get over here. You have to they're really sharp lines, right at the origin, because x1, y is 0 there. Okay. So that's why it's really hard to draw this one. But the best way to remember this is just remember it's a saddle. There's a parabola that's going up, and then there's a parabola that's going down. Is that okay? So here's just a quick way to graph these things. So this is D. Graphing surfaces. First thing is write the equation in standard form. So basically move all the square terms to one side after completing the squares. Now remember, every graph that I told you, a lot of the center points were the origin. Do you guys follow? If you complete the squares, the center points could be anything. After completing the squares, if required, you might not have to complete the squares every single time. 2, find the traces. like we just did. Do you guys follow? And note, you know, if the square terms, actually, let me write it. If there are terms of the form x minus h, y minus k, and z minus k, j, then the center is shifted to h, k, and j. Okay, then the center is shifted to h, k, and j.
So you said for the test we won't have to graph them?
No, you just have to identify them, and I'll give you guys some sheets tomorrow on how to identify them, or I'll send them to you, okay? But I know, Clay, you have a class, but if the rest of you, if you just want to stay here, I'll just do a couple examples really quick, and Clay, can you get them from them?
Yeah.
Okay. I have some graphs over here. So here are the shapes if you want. That's what I think. So then you know which one's which. Is that okay? Right. But let me just do two examples really quick and then we are done. Even though the book might tell you to sketch it, you don't need to sketch it. I just want you to describe it. Okay. So if I have 4x squared minus 3y squared plus 12z squared plus 12 is equal to 0. So I want to sketch this. What's the first thing I do? Make sure what we said, move all the square terms on one side. So let's do that, and everything else on the opposite side. So we get 4x squared minus 3y squared plus 12z squared is equal to negative 12. Is that okay? And I'm going to divide everything by negative 12. So I get negative x squared over 3 plus y squared over 4 plus z squared negative z squared over 1 is equal to 0. Not 0, it's equal to what? 1. So now we can start doing it. So once we do that, that's taking care of step 1. I didn't have to complete the squares on anything. I'll show you an example where you need to complete the squares. So now you just look at the traces. So what's the xy trace? You said z to 0, so what do we get? You get y squared over 4 minus x squared over 3, right? So it's a what? Hyperbola. Everybody see that? If you look at the yz plane, what do we have? YZ trace. And even though I say these are the planes, we are looking at the trace of the plane when the plane slices the surface. Is that okay? So what does that look like? In the YZ plane, what does your trace look like? This term will vanish, right? So what does that look like? So we have two hyperbolas. Okay. If you recall, when we did this one, we had ellipse, then we had a hyperboloid of one sheet, which had two hyperbolas, and then we had hyperboloid of two sheets, we also had two hyperbolas, right? Okay, so it's going to be one of those. You just have to decide whether it's one sheet or two sheet, and that depends upon how many negatives we have. How many negatives do we have here? 2, so it's going to be hyperboloid of two sheets. But let me finish it. Oh, what is the last one? XZ plane. So what do we get in the XZ plane? We get none, but we will, so you need to do, what did I tell you to do? Always check other traces, right? If you don't get anything, then check other traces. So when will we get something? So rewrite the equation and ask yourself, when will I get something? So if I rewrite it, I get this. I get x squared over 3 plus z squared is equal to 1 minus, y squared over 4 minus 1, which simplifies to y squared minus 4 over 4. I'm just rearranging it to see when do I get traces. You don't get any when y is 0, but you do get some for other values of y, right? When do we get some? Right, or less than negative 2. So we have if y is greater than 2 or y is less than negative 2, then what do we get? Then this will be a positive number, correct? So what does that look like? What does this look like? And then so this is that hyperboloid of 2 sheet. So you don't have any graph between negative 2 and 2. If you were to draw this, how would you visualize this one compared to the ones I drew earlier? Because everything is going in what direction now? What is your main direction here? In all the graphs I drew, my main direction was z, you know? Out here, what is my main direction? You don't have anything between what? Negative y value 2 and positive 2, right? So it's basically something like this. You have the y-axis, you have a dish like this, and then you also have something like this, and this is Zn. So the only difference is, like the picture I drew, it was opening up, right? The bowls were up, one bowl opening up, one bowl opening down, and this is on the other side, because it's along the y, because there's nothing between what? Negative 2 and 2. Does that make sense? Okay. And this last example. Everybody good with that? So you don't have to, oh, I forgot to write down what it is. What do we write down then? The conclusion is what? This is I do want to know the name, okay? This is hyperboloid of 2 sheets because of the 2 negatives. So this is what I want you to see on the dress. If you on the test, if you don't graph it or for your homework, that's what I want. I just want to see this. Is that okay? If you don't graph it, that's not a big deal. But I should definitely want to make sure that if you get nothing, at least figure out for what z values you do get something. And then this is the last example. Let's say if I have x squared plus 2y squared plus z squared minus 4x plus 4y minus 2z plus 3 is equal to 0. Out here, because of those x, y, and z terms, I'll have to do what? Completing the squares. Do you guys all agree? So let's take a look at that. So I'll have x squared minus 4x plus 4. Okay. Plus, and then I'll also have to do what? Minus 4 because we added the 4. Okay. Plus, I have the y, 2y squared and 4y, right? But remember, to complete the squares, can the leading coefficient be anything other than 1? So I'll have to take out a what? 2. So I get y squared plus 2y, because I have to take out a 2 from here too on the 4y term. And then I'm going to add what to this? 1 and subtract a 1. Okay. Plus, I get z squared minus 2z plus 1 minus 1 plus 3 is equal to 0. Always remember, when you complete the squares, the leading coefficient has to be 1. If it's not 1, you need to factor out that leading coefficient. So now let's complete the square. So I get x minus 2 squared plus 2 times y minus 1, y plus 1 squared plus z minus 1 squared is equal to, now see if you guys can tell me what do we have, what numbers do I have on the right hand side. This negative, this 3 will go to the right, will become negative, correct? Then this 1 will go, I'll underline that'll become a positive 1. This negative 4 will go, so that'll become a positive 4. What else goes on the right hand side? No. 2 because of this 2. Do you guys follow? So it'll be a positive 2. So make sure because of that 2, the 1 is in the parentheses, right? So there's a 2 there. So this gives me, what does it give me? We get 7 minus that is 4. And I'm going to divide everything by 4. So I get x minus 2 squared over 4 plus y plus 1 squared over 2 plus z minus 1 squared over 4 is equal to 1. So there's my equation I want to graph. Okay. So what are my traces here? And again, when you're doing the traces, don't worry about, because what does this mean? Negative 2, 1, and negative. The center is shifted. So let's ignore that for a second. What's the xy plane? So let's ignore that. So just don't worry about that. If I didn't have that, if z is 0, what do I get? This term's gone, right? Technically, this term will go away when z is 1, though. Do you guys follow? But for now, we'll just look at the xy trace. Imagine that's not there. What do we get? Ellipse. So in the yz plane, what do we also get? And in the xz plane, we get also a. So in essence, what is this then? Ellipsoid, a football. Okay, centered at where though? That's the only thing that's different. It just shifted somewhere else. Good? So you should be able to do the homework from that section.